Buon pomeriggio a tutti quanti, siamo pronti per iniziare con i lavori di questo pomeriggio. Sarà una serie di workshop tecnici. Il primo è powered by Network to Code. Oggi abbiamo con noi Christian Adell e Federico Olivieri che ci parleranno di Design Driven Network Automation. Stage is yours, guys.
Grazie. Buonasera a tutti, faremo presentazione metà in italiano, metà in inglese, il mio collega viene dalla Spagna. Mi chiamo Federico Olivieri, Solution Architect and Network to Code, con me Christian Adell, Team Lead of Architectural Team. Procediamo perché vogliamo parlare di Design Driven Network Automation, molte cose da discutere. Una breve introduzione necessaria di chi siamo, Network to Code. Siamo The Network Automation Company. 10 anni siamo i pioneer del network automation. Quello che facciamo noi, aiutiamo piccole, medie e grandi aziende nell'embrace dell'automation, facendo improve operational efficiency tramite l'automation di frequent task, centralized infrastructure management, everything. Scusate, ma l'ho sempre fatta in inglese, quindi ho un attimo di difficoltà a farla in italiano e in inglese. Reliable service provisioning, configuration assurance, automation, questi sono i big topic, i big win che portiamo quando iniziamo a lavorare con customer. Il modo in cui approcciamo il customer, assessment, vediamo di cosa avete bisogno, quello che viene identificato nell'assessment lo deliveriamo, sviluppiamo l'automation framework, abilitiamo le aziende a essere capaci poi di look after themselves tramite l'enablement and training, quindi passiamo il knowledge che abbiamo acquisito e poi possiamo anche supportare e gestire il framework che abbiamo sviluppato. Una nota, siamo open source community, siamo open source driven, community driven, quindi crediamo nell'open source approach, è una community più di 10.000 persone su Slack, molti repository che sono disponibili per voi. Nautobot è la nostra open source application che ha il ruolo di network source of truth, dove viene fatto il modeling della network all'interno di un database API centric, in modo tale che questi dati possano essere consumati nel modo migliore per sviluppare il network automation framework, e inoltre è un automation engine, quindi con i dati che avete all'interno di Nautobot potete coprire quelli che sono alcuni dei più comuni use cases: OS upgrade, configuration compliance, Nautobot firewall models ad esempio. Quindi quello che mi piace pensare come l'80% degli use cases del network engineer sono gestiti da Nautobot. Di nuovo, tutto questo è open source, free, gioia per sales department, provare a vendere cose che sono free. L'ultima nota, Nautobot è un framework che può essere esteso a vostro piacimento. Se quello che noi vi proponiamo out of the box in termini di soluzioni, application, non è abbastanza, Nautobot ha la capacità di essere esteso come volete, quindi potete creare i vostri modelli, potete creare i vostri job e i vostri plugin. Finita l'introduzione, andiamo nella parte di nostro interesse, Design Driven Network Automation. Parola al mio collega Christian Adell, prego.
Thank you very much, Federico, for the introduction. And now starts the actual hands-on part. Why? Because we have been working with network automation projects for a long time. We have developed and implemented, actually, hands-on implementation of solutions worldwide in all the continents so far. And we understand that it's not an easy topic, because if it was easy, we would not be here existing as a company, as a business. And the reason that it's complex is because we have been running networks for decades so far. And this idea of why we have to automate the network today, why is a necessity, it's not actually like a fun thing. Maybe it could be a fun thing, but the reality is that you have to put some effort to implement that. And it's not a one-dimension problem. Here you see in this illustration like 5 different pillars. These pillars are something that we have developed for a while in our interactions for more than a decade with customers, but which are the different things that you have to focus on when you work with network automation. And you can notice something like data management. Everything is about data. We are going to see this today. It's the focus of the presentation. But there is also about automation, orchestration. You know about a lot of tools, but you don't see any tool here because our philosophy and the recommendation for everyone to automate networks is to be agnostic to tools, to vendors, to platforms, to everything. Because everyone is different, everyone has different needs, different requirements, and you have to make them your own. Then you have data, you have automation, you have observability, monitoring. So there are different components on any strategy. You change your network, you observe your network, but without the data, without the intention, you are lost. You need something as a reference, just to change the network and to see if the state is the one that you expect. But don't forget about two pillars that you usually just neglect, that are how this is actually serving business purposes. Because people that interact with the network are not always network engineers. They think in abstract ways. So when someone from marketing asks you to access some provider, he doesn't think about IP addresses or ports. This is your job to transform. How you interact and how you transfer this into your actual data is your problem, not the marketing guy or girl problem. And finally, the culture, because we are, as I said, we are coming from a long trip about networking, so people is not used to this kind of things. Even automation is not a new thing for most of us, I hope. Not everyone is ready to adopt these things. So you have to build a strategy that makes easier for your users, but also for your contributors, for your network engineers, to don't be afraid of clicking a button and things happen, good and bad things. How I pass this slide?
Green.
Okay, so let's do a quick recap about what we had before network automation. Maybe you are familiar with this workflow. You have a lot of interactions, phone calls, messages, mails, someone asking for a service to the network operator doesn't have all the information, has to ask more information. This is a back and forth, an endless back and forth. Then when the operator understands the problem, checks the holy grail of the architecture diagram in a Visio whiteboard, and tries to understand what was the intention of the architect at that point. Should I get the first available IP address, then the VLAN, which VLAN, some direction about what the operator, the engineer, has to implement. However, this is simply an idea. You have to put it into reality and you have to check spreadsheets. Sometimes maybe the data is in the network. You have to connect to the network device and see which is the last VLAN that I configured. So the next one. These things you can see are not very practical. Then you have the idea, you have the data, you render, you create your configuration plan to implement it, and finally you connect to the devices. Here there are physical devices, but this could be in a cloud provider going into a UI. It's exactly the same, but with different methods. However, this is the past for all of you, I hope. This is the past, when we didn't have network automation. Today, with network automation, still there are things that remain the same. However, some good improvement. The users and the network usually have a good data plan, a form. So you know that your people requesting services will fill you with the device, with the user, some basic information, the one that you need. You don't need to ask again. The information is in place. However, in the step number 2, you still have to check the diagram from the Visio that was an inspiration that you have to actually land into the data that you need. Then, as we said before, with tools like Nautobot as a source of truth, a place where you can model all your network intention, the network operator starts creating many data. What does it mean, many data? Depending if you're building a new data center, we are talking about 1,000 objects. And you have to do all this stuff in a, maybe writing it in a YAML, maybe creating it in a UI. But this is not very practical. However, this is a requirement. You need the data. Some way the data has to be created and established. And then the automation does its magic. Whatever automation tool you have, a controller, Ansible, doesn't matter, can generate the configuration artifacts, the CLI, the API, payload automatically. And finally, everything is pushed to the network. So we have moved into the right direction. We are automating all the process. However, I guess you already spot where is the bottleneck. No? The bottleneck is here. We still have to, as a humans, understand and translate the intention of some architect into the actual data that you need. And this is where design-driven network automation comes in. Design-driven, again, using network-to-code philosophy, is a vendor tool agnostic solution. It's a philosophy that I would see spread across the community to the industry in the next years. But we are going to demonstrate today how this works. And you can see that there are not a lot of things to change. The only thing is put a tool that we call Design Builder, but anyway, is a tool that gets the information from end users and operators. See the change. The operator is no longer who needs to control the automation. It's the one that asks network automation services. Maybe a new data center is going to be asked by a network operator. But for your end users, will be something simpler, like a ACL update, a tunnel, something that is smaller. This is the idea of the design. Design is not the same for you or for the others, because everyone should have the capacity to define what's a design for me, and who is the owner of a design. Here comes. Now, the network architect is not painting useless diagrams in a Visio, in a whiteboard. That's not the way to go. The network architect should be the responsible of creating what we call a network design that you can express in different languages. That's not the important point, but have to be something programmatic, something that you can put into an engine that, from the request, all the thousands of objects will be created as a single entity. Why is important a single entity? Because when you have a single entity, you can update it, you can decommission, you can version it. So all the life cycle of your designs come to life. And as usual, we don't want to leave this only as words, because words are easy, and we want to show how this works. We have been implementing this for a long time in this idea of creating services that, again, is something that up to you to decide what's a service. In this case, we are going to show you in Autobot. So Autobot is a source of truth, some place that you start creating data. As you can see, there is zeros everywhere, nothing. And here we are integrating Autobot with a Git repository in GitHub. You see that I go to this Git repository where I have my designs. This is what the architect creates, the designs. Then I get into that design, I get the URL, I get the branch, I could have secrets, and I import all those designs that some architects have been creating together, collaborating, into Autobot. So all that logic that we need in order to put the data together is created into Autobot. This is synchronizing the data, and different designs have been imported. No data so far, only intentions, only logic. Then you just select all these jobs. That is part of the automation platform that Federico told you. So all these jobs are integrated, are enabled to be run. And when the jobs are in Autobot, you can start implementing these designs. So you go into this part, that is Design Builder. There are different designs. For example, initial data creates many devices into different locations, well defined by the architect. You can just trigger the logic to create this stuff. And the first important thing is you have different modes. For example, import mode, you can get information from existing data. Dry run, you can do a check mode just to see it. And then you ask for routers per site. Good thing, it's complaining. The architect put in the logic a validation. So you cannot create more than 6 routers per site. We just move to 2 routers per site, and all the data to create these 2 routers per 4 sites that are 8 devices have been implemented. All these devices have been created in one atomic transaction, all of them, with the rest of the data that you need. If you check the design, you also see that in design protection, you can see all the data that you have manipulated, specified for this. What does it mean? If you are following a design-driven approach, the data that a design changes, if I try to change that data, now Autobot should validate the data and complain. That's not possible. This data attribute is owned by someone else. Just go and update that design. However, if you just honor what the design wants, the rest of the data in Autobot can be changed. So in this case, we have changed the serial number because that data was not enforced by the design. Good. We have here one implementation of a design. But then you can start building things on top of that. Here you see that deployment. That design was deployed. Here you can see what are the change sets, something like a commit with all the story. So here you can see for every object all the data that it was contained before the implementation and after the implementation, because we are going to see how to decommission things later. We can now run an update of the data. What's an update? The design, we run it with 2 routers per side. We could go up to 4, or we could go down to 1. The design has to formulate and understand when you change from one state to the other, what are happening with the objects. In this case, if we went up or down, I don't remember, we went down to 1, 4 routers have to be removed. Why removed? Because they were not existing before. So we go to devices, and from 8 devices, we have now only 4 devices in one shot. Now, what we are going to see is this implementation. Imagine that is a data center. You can start building services on top of that, designs. In this case, there is a P2P connection that you can select, for example, the customer name. Customer name is an entry point that will create a BRF for you. It doesn't exist. There is a complex logic that is up to the architect to create. Then you select the 2 devices that are coming from Nautobot, and Nautobot creates the BRF, the devices, the cable, the connection between them, and all this data is available for you in one shot. So now, when we go to that device, we can see that a new cable, a new connection has been created with selecting the first available IP address. So all the logic from the architect that before someone had to understand, now is automated. And here we move to the last part of the life cycle, that is decommissioning all the data. That's something that we always want to do. So the data sometimes becomes irrelevant. So then all the data should be removed. And in this case, you can see that there are no longer more information about that. However, you still have the information in the decommission mode, so you can track and audit all the changes that happen to your network. Doing a decommission on the first design implementation, what's the final outcome? Nothing. You have a clean Nautobot instance. We deployed 2 instances of designs, and we removed back to the previous state. Why this is important for you? So you should be asking why this is a game changer from my perspective. Because at this point, you can start creating designs that are aligned with your business direction. Maybe you are start offering these designs in a way that your end users, your network architects, engineers can understand. So you are enforcing consistent deployments. There is no longer the interpretation of a diagram. You know that you have to select the first available slice 30 from a pool. You just get the next available VLAN. All these decisions that depends on the execution day are automated, are codified. Then you also start thinking your network as a product. A product because it's a combination of different services. And again, as I said before, it's different a service for me than a service for each one of you. The point is that this solution works with any model in Nautobot. So the core models that are implemented or the models that you can extend, because not even most of the networks are similar, you always have some differences. All these differences can be accommodated in Nautobot, and this solution works for these differences. Then, and I think that this is very important, is that you should make the life easier for your users. So if I was requesting something, I guess that some of you have been working with cloud services. When you create a VPC in AWS, how much information you put there? The prefix, or no, the prefix and something else. Why? Because all the decisions are already taken by you. So you don't have to worry about these things. There is an architect that knows how these things are implemented. So you are the responsible on your network to know these things and put into a code, a way that can be tested, that can be extended at your will. Then you get this idea of the life cycle of a design. The data that gets into Nautobot can be, as we have seen, updated, versioned, decommissioned, and people will be able to get this step by step in a unified and consistent way. Using that approach, for sure, you are going to get a very architectural mindset, because architecture, again, is no longer a drawing or a picture. It's something that is code, that can be tested, that can be extended, that can be improved. and data becomes something that you can refer to. What I mean about that? When you are gonna, because as we said before, in a network automation strategy, you have different components. Data management is one, and design-driven is data-driven. So it's a way that the data is not micromanaged, is grouped together. But that's not solving all the problem. Federico said Nautobot goes one step further. That is, once you have the data, you can use the data to deploy to the network. So you can actually use this idea. I want to deploy what? I want to deploy this service. This design that I implemented is the one that I want to deploy. Or when I am checking that in the monitoring tool, I'm not I don't want, for sure, I want to know how the network is running as a whole. But from a user perspective, what I am interested, what I care about, is how my service is working. And if you have a place where the data of that service is connected together, your monitoring can aggregate the interface status that you care about, the BRF connections and announcements that you care about, not all the rest. So a user that is concerned on a service is not concerned on all your network, only on these small things. So this is a very important question, that everything starts with the data, but it's not the end. You need to get this data, put into the network with the configuration artifacts. It doesn't matter if it's a CLI-oriented or an API, and then get all this information in order to check all these things. From my perspective, this is changing. It's a game changer. However, it's not an easy way to get started. I don't know how far are you on your automation journey. For sure, network to code can help getting up to speed. But we always recommend that you should start first with data. Leave the designs for later, but get some data. Get the inventory of your network devices, because only with the inventory of things, you can do a lot of stuff. For sure, not only with the data, you have to build something on top, put an automation engine. Nautobot itself comes with a lot of goodnesses for that, but you can choose Ansible, you can choose any controller that you care about, or Terraform, depending on your network infrastructure. These are the starting points. Only with these two things, getting an inventory of data with the IP address, management IP address, and the credentials, plus some automation and checks, you can do a lot of things. And then, when you're at this point, is when you can start thinking on, well, how I can make this network something that makes sense for someone else outside of the network. How can I make this abstract enough that people can ask me for the service ABC, that maybe when I transform that into real data, involves hundreds of objects. Objects that I have to do manually, the same way that you can configure the devices via CLI manually and make errors, you can change the data and make errors. So you have to reduce that probability. This is actually what we want to explain. And maybe, Federico, if you want to wrap up.
Yes. Before going through the commercial, that nobody really cares, right? So do you have any questions for Christian? A lot. Ok. Potete venire a trovarci allo stand qui dietro, e così vi facciamo anche una full demo di design driven automation. Abbiamo disponibilità se volete fare una architecture consultancy, abbiamo una whiteboard sempre disponibile per voi. Abbiamo anche un free network maturity assessment, c'è un QR code, è un quiz praticamente che vi fa capire a che livello siete dell'automation, dove vorrete arrivare, quali sono gli step. Come dicevo, siamo community driven, quindi troverete tantissime informazioni sul nostro blog, così come supporto da più di 10.000 persone, inclusi chi lavora in network to code, per aiuto. Se passate, c'è un QR code di nuovo, fate lo scan e magari potete vincere uno dei nostri 3 libri, di cui Christian Adell è uno degli autori. Next slide. Voglio solo mostrarvi la mia foto di quando ero 10 anni più giovane, tutto qua. Ecco. Abbiamo 5 minuti, se volete fare domande io credo che sia... ci piace avere questo brainstorming approach qui molto aperto, quindi qualsiasi tipo di domanda.
Any question?
Prego. In italiano va bene ugualmente.
Come vuoi. Parte virtuale, tutto il mondo degli NVF oggi? Lo integrate? Riuscite a gestire la parte di stanze virtuali, router, six wind, Netrastic, parte di firewall virtuali?
Got the question. So he's asking if we can manage through design-driven virtualization, virtual devices.
Exactly. So the point is that with design-driven, with this tool, you can manage everything that you can model in Autobot. So Autobot comes with a opinionated, defined models for you that serves with most of the use cases like load balancers, firewalls, and VPNs. But maybe you have your own specific rare thing. That thing can be put into design-driven because it's abstract. You just define it, the application that you extend and the model, and you can put everything there.
Someone has done it before?
Sorry?
Someone. Did someone integrate it with the NVF environment?
I am not aware of that because you should model that. But actually, in Autobot, you have like virtualization models, cloud network models, but maybe they are not specific for the functions, the virtual functions that you care about. However, again, everything of this can be extended the model just to fulfill the attributes that maybe are missing or the ones that you want to extend. Because we believe in this idea of everyone is different, but there are a lot of commonalities. So let's come up with a solution that solves 80% of the things, so people don't have to reinvent the wheel every time. And then you just make your small adjustments to make it happen. And all these tools, like the one that we presented today, but we have more than 30 applications, are built with this idea. We are a service consultant provider, so we solve problems in many different cases. We need a tool like this that helps us to adjust to the specific needs of every environment, just to make us really fast to deliver services.
Thank you.
Altre domande? Abbiamo ancora 4 minuti. Abbiamo pagato tantissimo per questi 30 minuti, vi prego fatemi sfruttare fino all'ultimo, se no non mi riapproveranno il budget il prossimo anno. No? Ok, vi aspettiamo allo stand e siamo a disposizione per voi oggi e domani. Grazie per l'attenzione.
Thank you very much.